This is the sixth session in the legacy migration webinar series that we've been putting on over the past few weeks. Today we're going to talk about legacy PowerFlex 4 and 7 series migration to the new PowerFlex 520 and 750 series. We have with us Mr. Tim Casey to present this. Tim is very experienced. He's been around for a very long time. He knew the old stuff when the old stuff was the new stuff. So he's very qualified to give this presentation. So I'll turn it over to Tim.
Hey, thanks, Mark. Go ahead and go to the next slide if you don't mind. So hopefully by now, particularly if you attended any of the previous tech talks, you've seen this slide, this graphic. And in the past, we've talked about the legacy drives like the Bulletin 160s, the 1305s, and the family of 1336 drives. And just about all those are in the discontinued or the red column, where, if something happened, you would be hard pressed to get any support or any parts for those drives. So, it's really your priority to go ahead and move on to something that's active. Today, what you'll see, with the one exception, everything that we have coming up will either be active, mature, or active. But that still kind of makes the 4-class drives and a couple of the 7-class drives a legacy drive, because we have newer products out today that has some features and benefits that I would think that you'd want to take advantage of. So Mark, go ahead. So we're going to start out with the 4-class drives, and this is the current portfolio of 4-class drives. And if you use Allen Bradley drives, I would venture to say you have at least one, if not more, of these type of drives in some enclosures out there on the floor in your plant. Go ahead, Mark. So to start with the PowerFlex 4M, if you look at the graphic on the right, this is an active current drive, and we don't see that changing for the foreseeable future. There's a couple reasons for that. One is that it's a very popular standalone component class drive. If you have 160s or if you've seen the 160, those were feed-through drives. So is this one. This is a feed-through drive. So if you needed to upgrade a standalone 160 drive that was not on a network, or if you want to remove a motor starter and you wanted to vary the speed of your motor, this may be something that you could put in, provided you didn't need any real tight speed regulation. Because again, this is just a volts per hertz. So the more voltage, the faster the motor's going to turn. So, not real dynamic, but it's there. And it's got a nice power range too. At 480 volt, it goes all the way up to 15 horsepower. So it fits nicely. So again, that falls into the active category. Next, Mark. Here's a PowerFlex 4, definitely active, mature. It's kind of restricted on the size. It only goes up to 5 horse at 480 volt. And again, you notice that it only offers volts per hertz, but it does give you some control over the slip compensation. Personally, for me, I would be actively looking to go ahead and migrate over to one of the 5 series drives off this PowerFlex 4 if I had some of these. I don't know of any compelling reason why I want to keep it, unless there's just something personal, if you will. Go ahead, Mark. PowerFlex 40. So this is a giant step up on the 4 class. So from the 4 and the 4M, we got this drive, and you'll see it's both active, mature, and active. The active mature is the open style. This is the majority of the PowerFlex 40 drives that are installed out there now. They're just, you take them out of the box, you mount them into an enclosure, probably snap them on DIN rail. What makes them active is that they are available as a flange mount, and also if you look at the graphic on the right, you'll notice it's a NEMA 4X. It's offering, and so when I say NEMA 4X, it's actually NEMA 4X indoor. the non-metallic part of the drive doesn't hold up well over time with direct sunlight. So if you do something like that, certainly put a sunshade over it. But if you're in a washed down environment, you may want to hang the drive on the wall somewhere, and that gets you there. So again, I think for those two reasons, the PowerFlex 40 is still with us. You notice once you move up to the 40, now we have a sensorless vector control with tuning capability. So we can really tighten the speed loop quite well. You're going to get a better control. And also it does support the internal PID functionality, so you don't have to have it in a PLC controller. You can do that. So it's been a good drive, but it's definitely something that I would be looking at migrating over to the 520 series. And I think we can demonstrate that here coming up. Again, up to 15 horsepower at 480 volt. So that's the PowerFlex 40. Next. 40p. This is quite the character. Not everybody comes across a 40p, but it's out there. So the 40p on a component class drive is and was only the component class drive that supported safe torque off until the 525 came out. So chances are, if you have a 40p in your plant, it was probably for that reason, or you needed an encoder feedback, because this is the first component class drive that we could support an encoder feedback, and of course the safe torque off, which was a feature that you would purchase in field install. Again, you can see all the different features. The PID, we also had something called step logic. I won't go into that. Not everybody used it. But anyway, again, up to 15 horsepower, 40p. One of the challenges of this drive is that you notice on the front, unlike the others, there's no way for you to program or set up the drive. You either had to use some software, or you'd have to use a handheld HIM. But for certain applications, this is certainly the go-to drive. Okay, Mark. PowerFlex 400 is active. There is no plans to change in that category at all. This is what we go to market with from a component class drive for fan and pump applications. You can see some of the features like the sleep wake, the flying start, handoff auto. There's actually an HOA built into the front keypad of the drive, so you have that. And it supports multiple building energy software networks that we can do. And also we can supply it with the 3-contactor bypass, which is pretty common in some water plants, that type of thing. Again, because it's a fan pump application, it's just going to be volts per hertz. The flying start, if you haven't used flying start, I believe once you move to the PowerFlex 40 and on up, that's a feature that's in the drive. And basically what that is like if this drive was on a, say, a 75 horse fan, and if that fan wasn't powered up, it was allowed to windmill. And you may even go in the reverse direction. Well, if I turn on the flying start, it allows the drive to engage that spinning motor at whatever direction or whatever speed. In this case, it would ramp it down to 0. Then it would go ahead and accelerate up to the commanded speed. It really reduces the mechanical shock to your system by using the flying start. So it's a pretty popular function or feature into that drive. Again, I'll let you go through that. So that was the 4 class or the component class drives that we have. And then a number of years ago, we came out with a PowerFlex 520. And when I say you might want to consider migrating off the 4 class, we'll move over to the 520. The 523 is just, I guess, the smallest, simplest standalone drive that we have. But even at that, it has some features that the other 4 class drives do not. First thing that you may see is that it does have a USB port, so it allows us to upload, download, and flash it firmware in the drive. Also, on the 4 class drives, the display only gave you a numeric feedback. It didn't give you a whole lot. Here on the 5 series drives, you actually get the display that scrolls information. So if you go to a certain parameter and just pause, it'll actually tell you what parameter that you're looking at. If the drive happens to trip off for a fault, it will even tell you what that fault is, not just the code. So it kind of gives you an idea right away what you're dealing with if you don't have them memorized to do that. Okay, Mark. So here's the 523. Now, with this component drive, you'll notice that we have what they call an embedded DSI port. And I failed to mention, but all the 4-class drives have this DSI port. And this DSI port supports Modbus RTU out of the box. So any of those drives or any of the 5 series drives, that port will support Modbus RTU. And if you just look in the appendix of the user's manual, you'll see all the data registers for the reading and writing via Modbus RTU. So it's certainly there, but it's also used for some other purposes. The great thing about the 5 series drives, you'll notice at 480 volt now, we go all the way up to 30 horsepower. So you can have one common drive cover a wide range of motors that you have. The other thing is that we do support the 7th IGBT now. So like in the 1305, 1336 drives, if you needed dynamic braking for bus regulation, you would actually have to have an external brake chopper, which is expensive and takes up panel, and then you would tie your resistor to that. With the 7th IGBT, now we can just terminate the resistor to that IGBT, and we have a fully functioning dynamic braking capability to do that. Also, if you put these 5 series drives on a logic-based controller, which is quite common today, particularly over Ethernet, we now support data links where the other 4-class drives do not. Data links, in this case, you get 4 in and 4 out. An example, maybe you want to monitor the output current of the drive. I can just choose that as a data link, and it automatically generates that tag in my controller for me. As far as an example going out, I may want to dynamically adjust my acceleration time based on my application. This gives me the ability to write that acceleration time over the network at any time to do that. Okay, Mark. And so here's kind of a picture of the terminal block and a good picture of the DSI port. So that's common through all the 4-class and the 523 and the 525. And that's what I was referring to when I mentioned support for the Modbus RTU. So it's there. Okay, Mark. So here we got the 525, very similar to the 523 with 2 notable exceptions. One, now the 525 comes out of the box with the Ethernet IP port built into it, and it comes with safe torque off as standard, where it's an adder for the PowerFlex 70 or the PowerFlex 40P. So you get that out of the box, and of course it has a little more I/O than the 523. Okay, Mark. So you can see now we have, with the 5 series drives, we do have volts per hertz like the rest of them, sensorless vector control, and economizer. With sensorless vector control, you always want to try and do a tuning, static or rotational tune to the motor, so we get the best control of that motor, the best speed regulation, if you will, to do that. So it's pretty important to do that. Also, the 525 also supports a permanent magnet motor. So these permanent magnet motors have been out for a number of years, and we're seeing more and more of those. Some of the advantages of a permanent magnet motor, if you want to pay the extra for it, first of all, you don't have to worry about the slip compensation. So there's no slip in them. But more importantly, they're highly efficient, and they really give off a lot less heat than, say, a standard AC induction motor. But it does take some different characteristics in the drive for it to handle those characteristics. So if you have a permanent magnet motor, which is really, I see more of those on some fans than I do anything else, this 525 drive may be something you want to look at for the permanent magnet motor. We can also hang or snap in an encoder. So now we can do the closed loop feedback, so we can tighten even more of the speed loop. We can also support DeviceNet, of course. So if you have some legacy drives on DeviceNet, the nice thing about the 5 series drives that any of these option modules, they actually snap on the back of the control unit, so they don't take any more panel space in your enclosure, which, there's value to panel space, right? So if you don't have to use it, that's awesome to do it. Multi-drive connectivity, of course, and then data links. We still get to 4 in, 4 out, and we get some extra I/O if that's what you need over the 523. Okay, Mark. And there's a picture of the terminal block. You notice that the ports, there on the left, you have the Ethernet IP, and then to the right, you have the DSI. They're both RJ45 connections, so you want to be careful. Don't do what I do and plug it into the wrong. It never communicates. And then on the bottom left, you see the red terminals. That's your safe torque off. Comes out of the box with that jumper mounted. So you do not have to use safe torque off if you do not want to. But if you remove that jumper, you are committed to using safe torque off. So just keep that in mind. It's installed when you pull it out of the box. If you want to engage it, you can go ahead and remove that. For those who are not familiar with safe torque off, basically what it is, it's 2 channels of 24 volts at the drive monitors. And usually it's connected to a safety relay. And it monitors that. And for whatever reason, you may have your e-stop or some other permissive tied through that. And anytime it loses one or both of those channels, the drive's going to shut off automatically. It's what they call a category 0 stop, and no energy will leave the VFD going to the motor. So in some cases, it could relieve you of the responsibility of, say, having an output contactor, which again saves you money and saves you panel space if you don't have to have that. But it's all part of your safety assessment that needs to be taken into consideration, exactly what cell level of safety that you require. But it's in there, and it's quite popular to be used today on VFDs. Okay, Mark. So some of you may be sick and tired of seeing this, but this is that automatic device configuration. This is something that's only available in the 520 series and the 750 series. So none of the 700s or the 4-class drives will support this. And it kind of just illustrates, you know, what happens if you lose a VFD at night, how, if you use a Logix-based controller, compact Logix, control Logix, how that controller can help you go ahead and set that drive up and get it back to running. Basically on that DLR, I'm sorry, on the automatic device configuration, if you take it all the way as far as you can, as far as functionality, if you happen to use a managed switch inside your control cabinet for this, and again, I recommend you use an industrial rated switch, because you don't want that switch to be the weak point in your whole control system, right? So you want it to have the same heat rating and everything else as your control system. But if you use a managed switch, then it can hand out all the IP addresses to all of your components. So if you have to change the drive out, you don't need to know which parameters to go to assign the IP address to the drive. So that's step 1. Step 2 is that we now support Firmware Supervisor. So when you commission your drive, the PLC will actually go to your laptop and extract the firmware for that drive, and it will store it in non-volatile memory. So when you do have to replace the drive, the PLC will recognize it because it's got its IP address. The controller will then interrogate the drive for the firmware, and it will automatically flash the firmware forwards or backwards to meet your project settings. Then once that's done, then it will go ahead and download the parameters into the replacement drive. Now the controller only stores the non-default parameters. So even if you had a used drive on another line that wasn't running and you needed to use it, the controller will automatically put it back to factory default before it downloads the parameters. So you can, so if you didn't have a new one available, you could go and get another one off another line that's not being used. So if you use all 3 of those techniques, you know, you can really take a lot of the human interface out of that. You know, all we need the human to do at this point would be to physically install the new drive, and hopefully plug the Ethernet cable into the Ethernet port and not the DSI port like I would do. But anyway, so again, available on 523, 525. We haven't spoke about the 527. That's a conversation I think we'll have another day. And then of course the 753 and the 755. Okay, Mark. So again, this is kind of what we touched on. The Firmware Supervisor, I think is the best part of the whole feature, because if you ever worked with a control system with any device on any network, it almost always comes down to a firmware issue, because things run for a number of years, and there's a good chance that when you go get that replacement product, the firmware has been upgraded somewhere, and that's a major speed bump in your control system when you have to get it back up and running. So I just want to, make sure you understand that we do have that available. Okay, Mark. So when I mentioned that we got a USB port on these 520 series drives, what you see in that little picture is that somebody's holding the control unit. So you can take all our drives apart, but the 523 and 525 was meant to go back together and run, okay? So if you take that control unit off the power structure, on the back side, you'll see that USB port. It's a standard USB cable. And when you plug it into your computer, you'll get that pop-up screen. It looks just like a USB thumb drive. And what that allows me to do is I can just download the parameters into that control unit while someone else is actually installing the VFD in the power structure in the enclosure, and it's terminating the AC power and the T leads. And then I can be downloading the parameters, go out, snap it onto the power unit, power it up, and it'll be programmed for you. This is very useful on standalone drives. If obviously if you're using these drives on Ethernet with the logic-based controller, you wouldn't have to do this because the controller holds all the parameters for the drives. But just know that this is here. It's very useful, and it really cuts down on the time it takes to change out a drive if it fails for whatever reason. Okay, Mark. So I've mentioned several times that all the 4-class drives and the 5-class drives have a DSI port, and they support multi-drive configurations. And this is something that the 7-class drives do not. So this is kind of unique to what we have on components. In this graphic, what you see are the 525 drives, and this happens to be a DLR. I wish it showed a star topology, because a lot of times drives and cabinets are usually done on a star, until recently, on a star topology, which means each drive has its own Ethernet port in the switch. And as you know, there's a value or a cost to each of those ports when you have to size that switch for your enclosure. So this allows us to actually control more than one drive off of a single Ethernet. Okay, Mark? So here's the example of what I mentioned. So we can control up to 5 drives off of one Ethernet port, which is pretty powerful when it comes to, limiting the size and number of switches I have. So in this example, you'll see an Ethernet cable going into that Ethernet port on my 525 drive. And then off the DSI port, I'm daisy chaining to 4 more drives. They just happen to be 4 amps, but they could be a 200 horsepower pump PowerFlex 400. They can be other 5 series drives. And you'll see the part number for that kit. Basically, you just take a piece of RS-485 cable, and you get this kit. It has some RJ45 connectors, and I like these because they actually have screw terminations. You don't have to crimp them, and it comes with the terminating resistors that you put on each end of the network. And this gives you the ability to control those 5 drives off of that one port. As an example, a number of years ago, we did a project at a battery plant that had 95 drives that they want to control with the Logix controller over Ethernet. So by using this type of system, we're able to knock it down to, I think, like 19 ports, I think, for the VFDs in that control system. So pretty nice. Go ahead, Mark. So this graphic here I took from Logix 5000. They actually let me use PLC software for a day. And what I did was, notice this module definition. I added a drive. My first drive there, you see drive 0525. And then I just added multiple drives. I added a PowerFlex 400 on my exhaust fan, and also a PowerFlex 4M that's controlling my water pump. And I could have added 2 more drives if I wanted to. Okay, Mark? And once I accepted that, of course, if you use Logix Designer or RS Logix 5000, you recognize these tags. So once I accepted that, you notice it automatically generated all my tags. So I've got, on the multi-drive configuration, you see I got conveyor 1, I got exhaust fan. So it's all done for me. So now I've got all that control. Now you won't be able to use data links with this type of topology, but it's very useful, I think. Okay, Mark. Okay, so we're going to transition over to the 7-class drives now. Any questions on the other ones? If you want to put them in chat, we'll address those at the end of the presentation. So PowerFlex 70, very popular drive, still used. It's still active actually, and so it's still fully supported. But I suspect for two main reasons. One, save torque off. So it was the first architecture class drive that we had that we could put save torque off functionality. It's something the PowerFlex 700 never had. And so that, and you notice at the graphic on the drive on the bottom right, looks kind of like the PowerFlex 40. That's our architecture drive that you can purchase. That's an EMA 4X rated, again, indoor. But if you want to put it in a wash down environment, you certainly can to do it. So I think for those two reasons, it's still considered active. Again, a lot of features. One of the things that you get with an architecture drive that you don't get as well on a component class drive, there is a ton of diagnostics. So if you want to monitor your system, if you want to help troubleshoot your system, things like that, it's a very powerful drive when you go to the architecture, and you get a lot more control algorithms for your application, and so just be aware of that. Mark, go ahead. So here's a PowerFlex 700 drive. It's considered active mature, but you notice the one exception when we started this talk. So on the PowerFlex 700 frames 7 through 10, which start out at 250 horsepower and above, those things have been discontinued. So if you have any of these in your plant or in your facility, I would make that my priority for migration. If not that, at least have a plan in place, okay? Because if we go back to the other tech talks, we want to take a look, see what the existing install looks like, particularly on if it's on a legacy network, because it kind of adds a little more time into that migration. So I encourage you to at least have a plan. You can certainly engage any of the Reynolds account managers or your Rockwell sales engineer or any member of the specialist team. We can help have that conversation, make sure that you're comfortable and confident that you're on the right path to do that. So anyway, you notice the 700 drive, full featured. If you could do it with between a motor and drive, the 700 could certainly do it. But again, it was a drive of the 90s and the early 2000s. So it's there. We can still support it. We still get replacement parts for it, but we probably have a better solution for you. So we even actually offered these PowerFlex 700s with an active front end. So if you were trying to offer something with low harmonics, that type of thing, we could do it. Okay, Mark. So we just discussed the 70 and the 700, and what we would probably migrate to is to the 753 or 755, what we refer to as 750 series drives. So here's a 753. It's what we would call a general purpose drive. It's kind of mean to call it that because it does a lot of stuff. Real good drive. A lot of features built into it. The one thing that 753 drive will do is not only does it can it do the full vector control, volts per hertz mode, but also has a feature called adjustable voltage control. An example where you use that is that we have a customer who makes or manufactures skids, and he ships these skids all over the world. Well, he's going to ship the skid to a place where it's 400 volt, 50 hertz, but he wants to test his skid out before he ships it. So he can run a PowerFlex 750 series drive in adjustable voltage mode, and he can actually supply power to that skid, power it up, and he can run his test before he ships it out. So it's a great application for this type of VFD that it certainly can do. With the 750 series drives, you also notice I got highlighted there that we do support auxiliary power. That's nice because I know I can slide a auxiliary power card into that drive and connect a 24 volt power source, external power source to it, and it keeps my network up and powered, and it also keeps power on my control pod. So I can keep my network happy. I can do what I need to with parameters, but there's absolutely no energy to the power components in the drive. So if this drive was in a motor control center, as an example, and I opened up the disconnect handle, I can still keep my network up and I can still monitor the drive, but there's just no power, no energy going to the power components, which is a big safety deal to do that. 753, it's got 3 expansion slots, so I can add safe torque off, I can add encoders, I can add additional networks, whatever I want to with it. I'm starting to come around to understanding that 753, the 3 may stand for 3 expansion slots. I'm a little slow, but I'm thinking that's what it might be. Okay, Mark. 755. Okay, it's a whole, it looks a lot like the 753, but it also has 5 expansion slots instead of 3. The other thing is it comes with the embedded Ethernet port, just like the 525. 753 doesn't come with Ethernet, but I can certainly add it if I want to. So the 755 will come with an Ethernet, and you get 1 digital input, and it could be 110 or 24 volt. But the thing about the 755 is it shows on the drive ratings up to 350, actually it's actually 400 horsepower at frame 7. But once you move up to frame 8, frame 9, frame 10, we can go up to about 2,000 horsepower to do that. But it's the same control pod. So if you can program any of these, you can program the much larger ones to do that. The other thing that the drive does, like the 525, it can manage permanent magnet motors, and also has a feature set called torque proving. So if you have a vertical load, vertical lift, now we don't have a lot of drawbridges going across the Red River, but we do have a lot of overhead crane and hoist and things like that. So basically any vertical lift. And what torque proving does, when you implement it, it has just like, I think maybe 5 or 6 parameters to set, but the drive is able to determine whether or not it has active control of the load before it releases the mechanical brake, and vice versa. It can ensure that the mechanical brake has control of the load before it releases or powers off to do that. So it's called torque proving. It's a great safety feature when using in those type of applications. Okay, Mark? So this is the final part of the talk or the presentation today, is drive software. And again, back on the previous tech talks, we talked about if you have a 160, you might have used Drive Explorer. If you had the 1305, the 1336 drives, you might use Drive Executive, Drive Tools. And those would even do the PowerFlex drive. You may have to download the drive profile, but you could do it. Well, with PowerFlex drives, they came out with Connected Components Workbench software. I didn't come up with the name. I like to call it CCW. But if you just Google that, you'll first hit will be a download site. You can download it. The great thing about this software, it doesn't cost you anything. It doesn't have to be registered, and you can use it on as many computers as you want. So, and if you have any drive that's called PowerFlex, this software package will do it for you. Okay, Mark. So here's kind of a screenshot of a quick project I threw together. Again, if you use Drive Standalone, this is the software that you want to use. If you're using drives over Ethernet per se and with the Logic Space Controller, the software will still look familiar because it's embedded into 5000. But here's Standalone. So just say I have a line, let's call it W line. I've got this enclosure and I've got these 12 VFDs in that enclosure. So now I can have one file. I can have all 12 drives. And I can even rename those drives. If you can see it, it's pretty small print. You know, I've got one called PowerFlex 70 outfeed. I've got one called Conveyor 1. So when I need to go back in and go online, I may want to monitor the drive, or I want to download the parameters into a new drive. I know exactly what I'm connecting to. So it really helps by being able to rename those. And then, you know, again, if I got an enclosure with multiple drives, I just need one file. I may call it, you know, CCW for W line, and all those drives will be populated there. Again, great for standalone drives. Okay, Mark. Okay, one feature that a lot of people skip over here, and I wanted to just do a quick down and dirty demonstration of this. So you go through and you configure your VFD, and you know, you take a 520 series drive, there's probably 300 parameters. If you go with the 7 class drive, you probably got a couple thousand, if not more. So after I commission my drive, I'll click on Show Non-Default, or I'll do a compare. And you can see on the screen there, in this particular drive, I've only had to change 4 parameters. And so it shows you which 4 parameters and what those values should be. And I've seen customers actually, after they commission their drive, they'll actually print that out they've even laminated it, hang it next to the drive, or put it in the control cabinet. So if second or third shift has to change the drive, they don't have to wonder what they need to do with it. They know exactly which parameters and what those values need to be to get that drive back up and running quickly. So it really cuts, it can really cut down on commissioning a new drive that's standalone. Okay, Mark. And the other thing that Drive Executive and CCW support are startup wizards, and they're startup wizards for all our drives. And this is just a screenshot. You can see in the left window where you go step by step. If I'm connected with this software package to my drive, I can actually, as I go through and answer these questions, I'm actually programming my drive. I can also check rotation of the motor. So if it's hot and it's up on the roof, I can send the junior guy up there or girl with a radio, and I can test rotation, and they can let me know if it's going in the proper direction. And I can also do the tuning process too. I could do a rotational static tune from this software package. But what I think is pretty neat is if you hang your mouse over any of those fields, it actually shows you the parameter that you're adjusting. And you notice there at the digital inputs, it actually shows the terminal block. So that's a dynamic terminal block. If I was choosing my speed reference, say a 4 to 20, a speed reference, it'll show me the two terminals, the signal and the common. But if I go back and change it to 0 to 10, you can actually see the wires move from terminal to terminal. So you know exactly, where you need to terminate your field wiring. Okay, Mark. The other great thing about Connected Components Workbench is that if you haven't noticed, when you buy a new drive today, if you're lucky, you get a quick start guide, but there's no user's manuals. So all the user's manuals for all our PowerFlex drives and everything that you can connect to a PowerFlex drive is embedded in the manual section. So if you just go in the software, go up to help, click on device manuals, and this is what you get. And so you don't have to go on to the web and search for drive manuals to do it. So we know sometimes even today, web access can be restricted in some environments. So another reason to have the software on your computer, even though you may not be connected to the drive, at least you can get to the manuals. Okay, Mark. And I think you're finally done with me. I think covered everything we want to. And
Thank you, Tim.
You bet.
That was a very good discussion. I always learn something when we go through these drive discussions. And I want to thank everybody for attending today. On Thursday, we're going to discuss migrating legacy MCCs. And the following Tuesday, we're going to talk about RSView 32, Wonderware, and iFix migration to FactoryTalk View SE. So I invite everyone to register for those webinar events. And thank you for attending today. Please contact any of our account managers or any of our automation specialists for any questions you may have on products in your facility. Thank you for attending. This ends this meeting. Thank you.